For number 34, you're told that you have an ellipse and you're given its standard form, and you're asked to find the center, vertices, length of the major and minor axes, and then the foci. So your best bet, I think, is to sketch this. It's pretty easy to pick out the center from what you're given, but the other things are pretty difficult to imagine without a graph. So your center is going to be 2, 3. And we're just getting the center is h and k, and you're getting those equations from the x and the y in the standard form. So if you want to just bear with me as I sketch this, center is going to be at 2, 3. So I'm going to do my best to draw an evenly spaced grid. Alright, so center is at 2, 3, so over 2, up 3. Big dot, so it hits it. To get the vertices are going to be made up from your major axis, and your major axis is going to be the long axis. So for your vertices, looks like you need to go a couple back this way too. Put another one in there. So for your vertices, from your center, you're going to go to the left 5, because that's the square root of 25, and you're going to go to the right 5. So if I count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, those are both of your vertices. Now essentially, all I did, the center, or the vertices, were both 5 units away from the center, so because my drawing isn't really that fantastic, it might be better to write it like this. So your vertices would be at the coordinates 7, 3 and negative 3, 3. And if I had a better graph, it'd be a lot easier to tell that. The length of the major axis is just the distance between those two vertices. So since you went 5 to the left and 5 to the right, the major axis length is 10. The minor axis, this is where you're going to use that other denominator. So from the center, you're going to go up 4, and you're going to go down 4. And that's going to be your minor axis. So since you went up 4 and down 4, the minor axis length is 8. The last thing we need to figure out are where those foci are going to lie. There's a couple different ways you can do this. On your formula sheet, there are equations. Well, that's a terrible ellipse, but there are equations for the foci. Now when you look at this, this is a horizontal ellipse because it's wider than it is tall. And the equations for the foci for a horizontal ellipse are h plus minus c and then k. We already know h and k. It's 2, so h and k is 2, 3. So we know that bit. So 2 plus minus something, c, and then 3. We don't know c, but again, on that formula sheet, it says that c squared is a squared minus b squared. And those are just simply your denominators. So c squared is equal to 25 minus 16. A is always going to be the bigger denominator for an ellipse. So c squared is equal to 9. So you take the square root of both sides. Your c value is 3. Now since that ends up being a whole number, we can actually get the actual ordered pairs for those foci, which is pretty rare. Our foci are going to be at the points 5, 3, as well as negative 1, 3. So 5, 3, if I go back to 1, 2, 3, 4, 5, if I go back to my beautiful drawing, you're going to have a focus there, and then at negative 1, 3. It's not a bad idea to graph it when you're done. I just look at it because those foci should always fall along the major axis. So your vertices, your center, and then your two foci should all fall in line with one another. The only thing that you should have going the other way is your minor axis. And we really don't have a special name for those endpoints of that major axis. So there you have it.
Made with Doodlecast Pro.